about Ampere circuit law in magnetostatic. In generally, you can find out the electric field intensity E bar. You can use Gauss law. Similarly, for you can find out the magnetic field intensity H bar. You can use the Ampere circuit law or Ampere's work law. So, what is the statement of Ampere circuit law means? The Ampere circuit law states that the line integral of magnetic field intensity H bar about any closed loop is equal to the current enclosed by that path. It is the statement of Ampere circuit law. So you can going for the mathematical expression for that law. The line integral of magnetic field intensity. So the line integral of magnetic field intensity H bar is exactly equal to the current enclosed by that path. The current enclosed, I can take up one example here. The current can be entering of this wire, the magnetic field intensity can be generated around that wire. So this is the state, this magnetic field intensity of closed path is equal to the I. So this is the statement of Ampere circuit law. So you can going for the proof of this Ampere circuit law. So but before going by the proof, the magnetic field intensity you can take by using of Biot-Savart's law infinite case condition of magnetic field intensity. By using of Biot-Savart's law infinite case of magnetic field intensity, that equal to I by 2 pi r into a pi bar. 2 pi bar into a pi bar. This is the Biot-Savart's law infinite case. This is for last class. So H bar equal to I by 2 pi r into a pi bar. Similarly, you can be substitute H2 in the mathematical expression and you can find out the DL. So what is the DL? Means it is the differential length. You can find out the differential length. So assume that point P to here. You can assume, so this is the magnetic field. So it can be rotated around this wire. So therefore I can assume that the direction is a pi bar. The distance of point P to the differential length, that is I can assume that the small r. So therefore the DL equal to r into d pi into a pi bar. R into d pi into a pi bar. So I can substitute H equal to I by 2 pi r into a pi bar and DL equal to r into d pi into a pi bar in the mathematical expression of Ampere circuit law. I can going for the equation, the line integral H bar dot DL equal to I. This is the mathematical expression of Ampere circuit law. So here line integral H is the I by 2 pi r into a pi bar. This is I will take up by using of Biot-Savart's law. Dot DL means I will take up the by using of circuit r into d pi into a pi bar. So I will take up the LHS term. I can be substitute the terms here. So then a pi dot and a pi equal to 1, a pi bar dot a pi bar equal to 1 and r will be cancelled. Then that equation becomes the line integral I by 2 pi into d pi. So r cancel and a pi bar dot a pi bar equal to 1. So here I will take up the constant terms in outside. I by 2 pi is the constant term and integral of d pi is pi. So the limits is what? What is the limits of pi? The pi limits are the azimuthal angle. The pi limits are 0 to 2 pi. It is the coordinate system. Okay, the limits. So therefore that equal to 0 to 2 pi. You can be substitute the limits, upper limit and lower limit here. So I by 2 pi, so upper limit and lower limit here it is 2 pi minus 0. So that is equal to 2 pi and 2 pi is cancelled, that equal to I. So that means closed line integral of magnetic field intensity equal to I. That is the proof of Ampere circuit law. Going for the proof of Ampere circuit law, so I can consider here by using of, I will consider the proof, I will take off Biot-Savart's law, Biot-Savart's law, infinite case. What is the infinite case of Biot-Savart's law? In magnetic field intensity, the magnetic field intensity H bar equal to, in the Biot-Savart's law, that means I by 2 pi r into a pi bar. So this is for Biot-Savart's law infinite condition at the angle of theta alpha 1 or theta 1 equal to 180 and theta 2 equal to 0 degrees. You can find out the magnetic field intensity H bar equal to I by 2 pi r a pi bar. This is for last class. So you can use for this for by using of Ampere circuit law according to statement, that is a line integral H bar dot dl equal to I enclosed. You can show that this is the satisfaction condition. So then I will take off the infinite condition of H bar and then I can find out the dl. So what is the dl? Here it is. So dl means we can take off the circuit. So then this is the, I will enter the current I of this wire and it can be I will assume that the one point P here, and around this magnetic field intensity can be generated. So then I can assume that this direction is called as a pi bar. So therefore the distance I can assume that to the differential point to the other point P, that is I can assume that small r. So therefore the dl equal to, just I can assume that dl equal to r into d pi a pi bar, because of this the distance and direction is a pi bar, the unit vector direction is a pi bar. So therefore the dl equal to r into d pi a pi bar, and the h I can assume that the h is equal to, by using a Biot-Savart's law infinite condition, I by 2 pi r a pi bar. So then I can substitute dl and h in the mathematical expression of Ampere circuit law, and I can prove that line integral of h bar dot dl equal to I. Okay, so next going for that case. So here it is I by 2 pi upper limit minus lower limit, that is nothing but what, 2 pi. So then 2 pi is cancelled, that equal to I. So the integral of line integral of h bar dot dl equal to I. This is the proof of Ampere circuit law. This is the proof of Ampere circuit law.